Hi there, in this video we'll be looking into a problem called word ladder. Let's jump into the problem statement. So a transformation sequence from begin word to end word using a dictionary list. Word list is a sequence of words, begin word, and we have to come to sk, here is the end word, such that every adjacent pair of words differs by a single letter. So we are given with a begin word, our aim is achieve end word. So we are given with a list of words, we are given with a begin word, or also we are given with a word list. So we have to form a sequence in such a way that we have to form from one word, we have to jump to another word such that the adjacent words differ in one single letter, right? So the last letter in the sequence should be the end word. So end word will also be present in the word list, but not begin word. Begin word is different from the word list. So we are given with a begin word and a word list. We have to choose one word at a time such that the next word and the previous word differ by one letter. Our aim is to arrive at the end word. So every SI for this list for I to K, 1 to K is in word list. Note that begin word does not need to be in word list and the last word is nothing but end word. Given two words, begin word and end word, and a dictionary word list, return the number of words in shortest transformation sequence from begin word to end word, or 0 if no such sequence exists. We have to find the shortest transformation sequence, not that we can take n number of no, we have to give back the answer such that what is the minimum number of distance or number of words required to arrive at end word, right? If there is a possibility that the end word might not be present in the word list, or there is no way we can arrive to end word using the set of words in the word list, then in that case we have to return back with 0. So the examples here are like begin word is hit, end word is cog, word list is hot, dot, dog, lot. These any random sequence of letters. No, like it's not a condition that these have to be a logical English words. No. So one short, like in this example, hit, from hit we can go to cog. Let's say from hit we can go to hot, right? Then we go to dot, right? Then we can go to dog, right? Then we can go to cog, which is 5 words, 1 2 3 4 5. We have to include the begin word as well as the last word, the end word. The second case, cog, if you see in the word list itself it is not available, so then we have to just ignore it. So the constraints are like begin word is in the range of 1 to 10, the length of end word is equal to begin word. Yes, obviously all the words should be of same length, right? They are differing by one character, there cannot be an extra character or so they have to differ only by one character. And word list length is in the range of 1 to 5000, and every word in the given list is equal to length of the begin word. Cool. And so all the characters in the given words are of lowercase English letters. Okay, begin word is not equal to end word. If they are equal, then there is not. So these two are not equal. All the words in the word list are unique. Okay, so I hope the problem statement makes sense. So let's take a simple example where we are starting with ABC. We take ABC and let's take our set of our end goal as something like A, E, J, right? A, E, J, or let's say D, E, J, right? D, E, J, and let's say we have our list as something like A, something like A, B, C, and D, D, C, and let's say D, E, I, and say D, E, J. right? So if you see, and let's say we have other possibilities also, like A, K, C, or B, B, C, right? Other possibilities. So these are our list. So if you see, from ABC, in this list we can go to ADC, right? Correct? We cannot go to DDC, we cannot go to DEI, DEJ. AKC is possible and BPC is possible, right? From ADC we can go to DDC. DDC is possible, but not anything else. AKC is possible again. AKC is possible, right? AKC is possible. From AKC, is there any other chance here? And from ABC, we have already consumed it through this path. Then there is no point in consuming this again, right? From here we have got it here. Why would we are looking for shortest path, right? Why would we go to this with an extra one in between? So there is no point in having that. Once we consume it, we will remove it from our list, right? We want shortest transformation. So DDC is here, ADC. So I'll go ahead and strike off this. So ADC is gone, DDC is gone, DEI I haven't touched, so these are gone. So from DDC I'll go to DEI, from DEI I go to DEJ, right? So if you see the constraint given to us is all the characters in the words are lowercase. So here this has 26 possibilities, so this has 26 possibilities, this has 26 possibilities, right? We can easily compute all these. We can easily come up with all these variations. The length is reasonably small. It's not like a big string, right? We can easily compute. So the word length would be given as 1 to 10. So pretty small word. So we can easily, it will be max to the power of 10 to the power of 10, which is fine. So we can easily find all the combinations. So all the combinations we can, so if we take these many combinations, we can easily check all these, and we can consider only those which are present in this list. If let's say we come across ADC, we have replaced this point, this character alone, then we can easily check whether it is present. If it is present, then we consider this into our temporary queue. Let's take this as our temporary queue. We have it as a queue here, right? So we'll have a queue here. So we arrive at this list, okay, which are differing by one word and which are present in the word list, right? Now we iterate on this queue, and take a next level of queue here, right? Next level of queue here. Once we repeat the process, once we find an end word, then we return back saying the length. We will maintain a counter here. Initially this will be 1, at this step it will be 2, at this it is 3, at this it is 4, at this it is 5. Let's say there is no such word, right? There is no possibility. Let's say that we don't have DEI, then there is no chance from DDC will come to. After iterating DDC also we won't from DDC we won't have any further queue to expand. Then we will return 0, saying that it is not possible. We return 0 if the end word is not present, or if there is no possibility where the queue becomes empty, right? If we encounter the end word, then we return back the counter which we are maintaining, right? And one question you might, like we just saw, from ABC we came across AKC, from ADC we can again go to AKC, but there is no point of considering this path when we already have this path, right? This is the shortest path. Why would I go to this point, right? Anyways, from this the combinations would be same as from this, right? What is the point of going to this when I have this? So I won't consider this. To have that, once I consume a string, I'll remove it from my word list such that I won't consume this word in another path, right? Makes sense? So let's code this. Firstly, I'll check whether my end word is in this word list or not. So for that, anyways, I'll take a hash set. I'll convert this list into a hash set. It will be easy to compare, right? So let me take the result as, I don't have to take it as 0, right? I need a counter. Actually I need a counter which says to 0, right? I have to return 0 at last if my queue is empty, right? If before that I have to convert it into a set of string set equal to new hash set. I can pass in the word list as is, it will be converted. So in my set, if it contains, it's fine. If the end word is not present, that's a problem. If end word is not present, I'll return the counter here. Now I take a queue, normal queue, so queue equal to array dq, right? Array dq. So to this queue I am adding my begin word, offer my begin word, correct? Now while queue is not empty, I'll iterate it. I'll reiterate it only for the current size. What is my int I equal to 0 to, how many times I have to go? I have to go less than queue dot size, right? I plus plus. So then I'll take a temporary string, a string builder actually. So I'll take a string builder, I'll call it as SB equal to new string builder, and I'll pass in I'll poll from my queue, right? I'll poll from my queue directly here, queue dot poll, right? So now I have to replace with characters, char I equal to, from A I am starting and I am going till less than or equal to Z, right? I plus plus, right? Then I have to set at each character, and also do I have to maintain a cache? Do I have to maintain a cache of that word? Because I have to I'll be replacing it. Do I need it again? Let me see. So I have to replace it. So sb dot set char at the length, this is I, let me take this as j, so I am replacing at I with j. Okay, once that is updated, right? If let me take it as a string current, what is the current? Is sb dot to string, right? So if the current is equaling my end word, I am at the answer. Here I have to increase my counter, right? Once I have to increase the counter here, and also I have to do return plus counter, because I am consuming. I have to include the end word also. So if it is not equal to, then I have to look if this is present in the set, right? If set contains, if the set contains the current, right? If it contains the current, okay, if it is containing the current, I have to offer it to the queue. Q dot offer the current, and also I have to remove from the word list, from my set rather. Set dot remove, because I have consumed it into my iteration, into my queue, so I have to remove it so that it doesn't come again, right? So once this is done, so I am replacing this SB. So only one character I have to replace, right? So I should be q dot poll should be outside, right? Q dot poll should be outside, it cannot be inside, because I'll be changing only one word, right? String, you can take this as maybe parent string, right? That's a what on which we will be going to the children, which are currents. So for which I'll have it as q dot poll. So I'll have it into this, right? So SB is consumed, so I am setting my character, right? It will be replaced. So every time I'm constructing a new string builder, so it will be replaced, it will, so okay, it is remove, it is offering. If it is not present, then we don't consider it at all, right? And we move forward. If we encounter, we return back the counter. If we found a place where we did not come across, means then there is no possibility, so we are returning 0. Yeah, and here we missing a semicolon and a new array deque. This is fine. So we are offering the begin word, we are iterating, then parent, we are pulling the first one, and we are iterating the queue size, then we are replacing with, okay, one thing which we missed here is that we have to go by element, right? First we have to replace the first index with A, B, C, D, E, F, all those, then the second index, then third index, right? So for that we can take the SB, right? We can take the SB for int I equal to 0. We can start with k here, k equal to 0, and k should be less than my SB dot length, right? And k plus plus. So into this comes this for loop where I replace from A to Z, but one thing here is we have to maintain a cache of the character which we are replacing, so that we can set it back. So here I'll have a simple cache of char, which is SB dot caret my k. So I am replacing the char at k, right, with j. So same thing we have to put back again once this iteration is done. Okay, so we have to set back the cache. which is k comma cache, right? So we are offering the begin word to the queue, and we are checking, we are incrementing the counter, we are taking the pooling on the queue, then okay, so here we cannot pool and then take the size. Also, if you observe, we have to do this rather than, because the size of the queue is increasing parallelly, right? So we have to go with this, right? And here this should be length. So AJ, we are setting the character to the cache, and here, and if it returns, we are incrementing and returning. If it matches, we are offering to the queue and removing from the set. Let's run this. Okay, the test cases are passed. Let's submit it. Okay, I hope the solution makes sense to you. Thanks for watching. Let's meet in another video.